Let's go ahead and finish up page 1 of this new packet. So we had just highlighted input is X, output is Y for you to remember. So you look at your T table, input, number of gallons used, output, total cost. Next question is it appropriate to connect the data points in your graph? So this is the question you should ask yourself when you're answering this question. I connect the data points if there are fractions or decimals that are possible for X. So I ask myself, when I buy gas, do I only buy whole number gallons? Could I buy half a gallon? Could I buy 3.7 gallons? Could I buy 6.8 gallons? Of course. If you look at your, what is that called? The pump, the gas pump, when you go to pump gas, is it ever like a whole number of gallons? No, it's almost always a decimal. So if decimal answers make sense on the x-axis, that means you connect it. If decimals don't make sense, let me give you an example of where decimals wouldn't make sense. I'm picking apples and I count them. Can I have a decimal apple? No. When I'm picking apples, I'm only going to have whole numbers, so I would leave the dots. But here, a half a gallon could be bought, 3/4 of a gallon could be bought, 3.5 gallons could be bought. So that tells me to connect my points. And then the other question you have to ask yourself is, do I need an arrow? So, could I buy more than 10 gallons of gas? Absolutely. Most of us do, or a lot of us do. Oh, let me get a better. So, you are required to use a straight edge when you're drawing lines. So, get out your straight edge and we're going to draw a line starting at 0 and going on for however many gallons we buy. So if we could only buy 10, if our tank only held 10 gallons, let's say, then we would have stopped. But at this point, we don't know, so we can buy as much as we want. So another question I want to ask you is, could we go backwards? Can I buy? So backwards will mean a negative number of gallons. I can't buy negative gallons. That's why this one doesn't have an arrow on it. I can buy more than 10 gallons. That's why this side has an arrow, but I can't buy less than 0. So this side will not have an arrow. So now we have to explain that. Is it appropriate to connect the dots? Yes. The dots should be connected. Because, so this says, is it appropriate to connect the data points? Explain your answer and then connect the dots if appropriate. And so we would say, because decimal values on the x, and I only look at the x-axis. I don't look at any other x. Yes, we only did whole numbers here, but I could have said 5.5 gallons. I could have said 6.7 gallons. I mean, it just was easier to do whole number gallons, but decimal values of x, gallons used, make sense in this problem. So if I was counting the number of apples or counting something, then no, you wouldn't connect it because decimal values don't make sense. But on this one, we're measuring it. And gallons can absolutely be in decimals. Okay, let's move on to page 2. So what we've just made, and this is highlighter time, so make sure you have a highlighter handy. So what we've just made is what's called a continuous function. And you're going to have several questions on your test about continuous and discrete functions. So a continuous function allows the x values, in our case it was gallons of gas, to assume any value. That means they aren't just whole numbers. So to assume any value in a given interval, including fractions, decimals, and irrational values. So in the Grand Canyon activity, the number of gallons could be represented by a whole number, but it could also be represented by any numbers in between, 6.7 gallons, 8.3 gallons, for instance. Because like I said, it's not very often at the gas pump that you buy exactly 5 gallons of gas. Like you might make it $5, but that won't be an exact whole number gallon. Can data always be represented by any number? Let's take a look. Okay, so we're back on our Grand Canyon trip. Put my paper clip back in to hold these pages together in this monster packet. So this time we're buying soda. So start thinking, okay, gas, I can buy decimal values of gallons. Soda, can I buy 1.5 sodas? Can I buy 5.3 sodas? Nope. So you're going to see this is a whole different kind of graph. Okay, so after driving, you and your family stop at a convenience store to buy sodas. Each can costs 90 cents, so we can see that's going to be important. You do not want to spend more than $10, so you have up to $10 because you want to save as much money as possible for food and souvenirs. What is the maximum number of cans you can purchase? So cost per can, so that'd be take your $10 and divide by 90 cents to see how many. Cost per means divide the cost per can. So cost per can. So let's do 10 divided by 0.90, and we have 11.111111. So let's talk about that. So do I have enough money to buy 12 cans? No, I don't. I can buy 11 cans with a little left over, but that is not enough to buy 12. So I would say 11 cans of soda. Use the table below to determine your total cost for purchasing each number of cans of soda to the maximum. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, so they want us to start with 0. So again, we're putting whole numbers in the table just like we did for the gas, but the gas could have come in decimal gallons. The soda cannot come in decimal sodas, so this is the only possible table you could make for the sodas. So if you bought 0 sodas, obviously it'd be $0. Each soda costs 90 cents. So that means 1 soda is 90 cents. 2 would be $1.80. 3 would be $2.70. 4 would be $3.60. 9 times 5 is 45, so $4.50. And remember, money needs 2 decimal places. It would be counted incorrect without it. 6 9 times 6 is 54, so $5.40. 9 times 7 is 63, so $6.30. 9 times 8 is 72, so $7.20, 81. 9 times 10 is 90, so that'll be an even $9. 11 times 9 is 99, so that'd be $9.90. And you can see from this that there's no way you would be able to buy 12 cans because you're already 10 cents away from the amount you're allowed to use, which was $10 up here. Okay, let's see what they want us to do next. On a separate sheet of paper, they want us to graph. So we can take the graph below our last one. Plot the number of cans of soda on the horizontal axis. So this would be number of cans of soda. Okay, let's see what it says next. And the total cost for the number of cans on the vertical axis. So here's the vertical axis. So again, this would be total cost. And remember how we always have to write the units after it, telling the reader whether it's dollars or cents or not cents, dollars or yens or pesos, krones. Okay. Be sure to properly label each axis and give your graph a title. So, soda on the Grand Canyon trip? I don't know. Soda on the, we'll just say canyon trip since that's too long. And giving it a title does count as points on your test, so make sure you follow all the steps that your test asks. Okay, so we're ready to graph. So now we have to fill in our numbers. So cans go from 0 to 11, so we're good there. The cost goes from 0 to $9.90. So I wonder if we have enough here. 90, 180, 270, 360, 450, 540, 630, 720, 810, 9. No. Maybe we'll add a line or two. How about that? So let's just go by so there's 0. Here's 90 cents. Here's $1.80. Here's 270. 360, 450, 540, 630. So 9 times 1, 2, 3, 4, 5, 6, 7, 8. 9 times 8 is 720. 9 times 9 is 81. $9. And then we just have to add one line. We can get by with that, can't we? And so that'll make it $9.90. That way we don't have to guess and go between lines. Okay, so let's move this over and have our table on the same place. So 0, I'm going to put the table underneath. 0 goes with 0, so that's going to be our first dot. 1 goes with 90 cents, so that's going to be our second. 2 goes with $1.80. 3 goes with 270. You can see the pattern here. 5 goes with 450. 6, 7, 8, 9. 10 goes with $9, and 11 goes with $9.90. Okay, everybody get that? Okay, so we're running out of video time, so let's go ahead and stop there, and then we'll pick up on number 4 on the third page. on the next video.